note set 1, I think we have to do the odds on the third page, and then we have to do the back page. Yes?
19, 21, 23, 25.
All right. So on 19, we're supposed to rationalize the denominator, but sometimes it can be easier if you simplify first. How can I simplify the fraction first?
8 cube root
Okay, do you know the cube root of 48? Well, okay. You could do that, or we could simplify 8 over 48.
That is 1.
Divide by 8 on both.
6.
So this is the cube root of 1 over 6. And then we can split the cube root with the numerator and denominator. So we got the cube root of 1 over the cube root of 6. That's good.
multiply by 26.
What's the cube root of 1? 1. So this would be 1 over the cube root of 6. And then I actually learned something kind of cool yesterday that I'll show, because I didn't show it yesterday when we did the notes. But when we're multiplying, when we're rationalizing the denominator, what are we looking for when we're taking the cube root? Perfect cubes. I have 1 6 in the denominator right now. If I want a perfect cube, how many 6s would I have to multiply by?
3.
I want 3 of them. I already have 1.
2.
So I'd have to multiply by 6 squared, yes? Because this is 6 to the first.
Yeah.
So then if I multiply the top by the cube root of 6 squared, then the top, I'm just going to have the cube root of, what's 6 squared? 36. And then on the bottom, we end up with the cube root of 6 cubed. What does the cube root and the cube do to each other? They undo each other, and so we're left with the cube root of 36 over 6. So if you're confused about what do I multiply this by to get it to rationalize, just multiply by something that's going to make it a cube. Is there a perfect cube factor of 36? So our perfect cube is 1, 8, 27. Nope, we're good. Questions on that one? A little bit different than the way that we showed it yesterday, but I thought it would be helpful. Ready for 21? You guess. 21, I have a negative on the outside of the cube root of 6, and then I have the cube root of 2 in the bottom. Those two cube roots are dividing, so I could go ahead and divide those now if I wanted to. What's 6 divided by 2? 3, but it's negative on the outside, and we have the cube root still of 3. Is there a cube root factor of 3 other than 1? No. And do I have a denominator that's irrational? No. So that one's actually a lot easier than you probably made it. But you can go ahead and divide cube roots if they divide. Can I divide the cube roots on 22? No, so be careful there. We did 22 yesterday, but, oh, sorry, those are fourth roots. Good on 21? Scream if you're not. Okay. Oh, where's 23? Oh, fun. All right, we're multiplying. Hey, what kind of number is the square root of 5? Irrational. What about the square root of 3? Irrational. So what kind of number is the square root of 5 plus the square root of 3? Irrational. That's going to be pretty interesting, but we're multiplying it by the square root of 5 plus the square root of 3, and that's also irrational. So we're multiplying two irrational quantities together, yes? It's interesting to see what happens. First times the first, what's the square root of 5 times the square root of 5? 5, because it's the square root of 25. And then first times the last, what's the square root of 5 times the square root of 3? Positive square root of 15. You can multiply those numbers together. You just can't add different square roots together. And then inside, what's negative square root of 3 times the square root of 5? Minus the square root of 15. Good. And then last, what's negative square root of 3 plus the square root of 3? Minus 3, because it would be minus the square root of 9, which is 3. What kind of number is the square root of 15? Irrational, but they do make 0, don't they? So that leaves you with 5 minus 3, which is 2. What kind of number is 2? Rational. So we took an irrational quantity, multiplied it by an irrational quantity, and we got a rational quantity. Interesting. We did 24 yesterday, so 25. First times the first, 2 times 2 is? hopefully you're quiet because you're doing it, 4. 2 times negative I is negative 2I. I times 2 is positive 2I. And then I've got I times negative I, which is negative I squared. Should be able to do this from the last unit. Negative 2I plus 2I makes 0. This is really 4 minus a negative 1, which turns into 4 plus 1, which is 5. Remember, I squared is equal to negative 1. Questions there? What do we notice about all three of these? Except for the last one, right? That would be complex times complex. So we multiplied 2 irrational quantities or 2 complex quantities and got what? A rational number, right? Okay. So technically, didn't we rationalize these expressions? Interesting. What else do we notice about these three? Should have been on your homework last night. They're all binomials. What's the difference between the binomials? Positive and negative. So this is what we call conjugate pairs. That was on your homework last night. It asked you, like, what do we call the relationship between them? They're called conjugate pairs because they're the same thing, but it's plus and minus. So think back to, like, x squared minus 1. X squared minus 1 is a difference of perfect squares that factors into conjugate pairs because it's x plus 1 and x minus 1. So relationship is conjugate pairs. Questions on that? Go away, go away. Flip it when you're ready. Go away. All right, now we're going to rationalize, except what do you notice? There's a rational number on top. What's up with the denominator? It's an irrational minus a rational. Can I just multiply by the square root of 5? So notice, if I multiplied the bottom by the square root of 5, that would give me, don't write this down, that would give me 5 minus 2 square root of 5, right? And then I have the same situation that I was in the beginning, is the square root of 5 is irrational and I can't have that. So just multiplying by the square root of 5 is not going to do this for us. We're going to use our knowledge of conjugate pairs and the fact that if we multiply by a conjugate pair, it's going to rationalize just like these examples did. So if you had the square root of 5 minus the square root of 3 on the denominator, you'd want to multiply by its conjugate pair of square root of 5 plus the square root of 3 because you end up with a rational number. So that's what we're going to do here. If I multiply, I'm going to put parentheses around this because I like to see it that way. I'm going to multiply by the square root of 5 minus 2's conjugate pair. What would that look like? Square root of 5 plus 2. But what I multiply on the bottom, I have to multiply on the top. On the top, it's nice because all you're doing is distributing that 3. And so 3 times the square root of 5 is 3 square root of 5. 3 times 2 is going to give me a positive 6, and that's in your numerator. In the denominator, you're distributing, but it's going to happen 4 times. So we're going to go square root of 5 times the square root of 5, which is 5. And then the square root of 5 times 2, which is positive 2 root 5. I'm going to have to extend my bar there. Inside would be negative 2 times the square root of 5, which is negative 2 square root of 5. And then last would be negative 2 times 2, which is negative 4. So you'll end up with 4 terms on the bottom, but what happens with conjugate pairs? The middle 2 are going to make 0, and then you can add the 5 and the negative 4 to be what? 1. The great news about a denominator of 1 is that we don't have to write it. So 3 square root of 5 plus 6 over 1 is really just 3 square root of 5 plus 6. Sure. You want to try number 27 on your own? Try it. I'll give you about maybe a minute. Little rundown of 27 so you can check your work. Your conjugate pair should just change sign on the middle, not on the 3. And so that's the main thing that I saw going on. Your conjugate pair is going to be 3 minus the square root of 6. When you multiply the numerator, negative 2 times 3 is negative 6. Negative 2 times negative square root of 6 is positive 2 square root of 6. The bottom will just be first and last, so 3 times 3 is 9. And then the square root of 6 times the negative square root of 6 is going to be negative 6. 9 minus 6 gives you 3, so negative 6 plus 2 square root of 6 over 3. You can only divide this fraction by 3 if all 3 of your numbers divide. Negative 6, 2, and 3. 2 doesn't divide by 3, so we can't divide here. So this is where it stays. Questions on that one? So let's try 28. 28 is not irrational, 28 is complex. And so it works the same way. What would our conjugate pair for the denominator be? 3 plus I. I'm going to put parentheses around my top and bottom of my fractions to begin with so that I remember that this is a binomial times a binomial. You'll be doing 4 terms. And so 2 times 3 in the numerator will be 6. 2 times I is a positive 2I. I times 3 is a positive 3I, and I times I is a positive I squared. Over, if we're multiplying the conjugate pair, it is still 4 terms, but you should notice your middle 2 are going to make 0. So 3 times 3 is 9. 3 times I is positive 3I. Negative I times 3 is negative 3I, and negative I times I is negative I squared. Again, you should notice the 3I and negative 3I makes 0. On the top, I squared is really negative 1. And so I usually, and on the bottom as well, this is also negative 1. So on the numerator, you'll have 6 plus, let's go ahead and combine 2I and 3I to make 5I, and then minus 1 for that negative 1. On the bottom, you'll have 9 minus a negative 1. 6 and negative 1 combine on the top to give you 5 plus 5I. On the bottom, 9 minus a negative 1 is really 9 plus 1, which is 10. What do you notice? What cancels?
No.
What's up with 5, 5, and 10? Greatest common factor of 5, so you can take that out. 5 divided by 5 is going to give us 1, plus 5I divided by 5 is going to give us I, and 10 divided by 5 is going to give us 2. You can only take out a greatest common factor if all 3 of your terms have a greatest common factor. What questions do we have? I'll give you a second to get caught up on that. Volume, we're going to have to deal with cubes, right? It says the volume is 216 feet cubed, and they want us to find the radius. So we are going to need the formula for the volume of a sphere. Who remembers the volume for a sphere? Miss B does. 4/3 pi r cubed. From here, we know that our volume is 216. So we can plug in 216 for V. So we've got 216 is equal to 4/3 pi r cubed. They want us to find the radius. So we have to solve for r. Oh boy. Hey, what could we do first? You could do that. I'm going to multiply by 3 because I like to break it up into 2 steps, but you could multiply by the reciprocal of 3 over 4 if you wanted to. 216 times 3. 200 times 3 is 600. 16 times 3 is 48. And our 3 here and our 3 here make 1, so that leaves us with 4 pi r cubed. Awesome. Divide by 4, okay. You could. 600 divided by 4 would be 150. 48 divided by 4 is 12, so 162. Over pi is equal to r cubed. Good. Cube root. Does 162 have a cube? It does. 162, 2 and
81.
that's what tells me it has a perfect cube, because 81 is divisible by what?
39.
It's divisible by 27, which is a cube, right? If 81 is 27 times 3, we have 2, 27, and 3. Which one's our perfect cube? 27. So let's break this up first. This will be the cube root of 162 over the cube root of pi. And that's equal to r. But we can simplify that cube root on the top. So the 27 will come out to be 3. What stays underneath? 2 times 3, which is 6, over the cube root of pi. Now we could rationalize the bottom, right? We could multiply by the cube root of pi squared and get pi cubed, and then the bottom would be pi. What do you know about pi? It's not 3.14. Okay, what else do we know about pi? It's irrational. And no matter how hard we try to rationalize the denominator, it's not going to happen. So, this is a great multiple choice question. Because what happens if you had decimals for your answer choices? What would you do? I would just type it in my calculator, right? If you had multiple choice answers that were fractions, you would have to find which one would be equivalent to this, right? You might have to multiply by the cube root of pi squared and get pi on the bottom and all that good stuff. But we're going to keep it here for now because we cannot rationalize that denominator. Homework. You got 30 minutes. I'll be around.